everyone, my name is Vanessa Roldan. But before we start, we all know that recently we got news that scientists believe that we have 3 to 4 years to save the planet, or we're currently stepping on. As humans, we need to act as soon as possible within those 3 to 4 years, even if it means taking small steps like planting trees, deleting unwanted emails, using Eco-Asia, and so on. Scientists protest and warn the public about the dangers of fossil fuels, urge us to act now because failure to do so will result in the destruction of our planet and irreversible climate change. To enlighten our minds or learn more about climate change, here we are, Group 7 and 8, who are going to discuss climate change and various terminologies or things that are related to it or in a climate change. These things are really important for us to know in order for us to know what the things that we need to do or avoid are. So today, join us as we tackle the climate change.
Good morning everyone, I'm Angelica Superel and today we're going to discuss the causes of climate change, and those are volcanic eruptions, orbital changes, the carbon dioxide theory, human activities that contribute to climate change, and the effects of climate change. Climate change is very relevant today, but before that, let's see first what causes climate change. The climate on Earth has been changing since it formed 4.5 billion years ago. Until recently, natural factors have been the cause of these changes. Natural influences in the climate include volcanic eruptions, changes in the orbit of the Earth, and shifts in the Earth's crust, known as plate tectonics.
Good morning, everyone. My name is Miguel Ralph E. Samson, and this is my part of our group report about causes of the climate change. Over the past 1 million years, the Earth has experienced a series of ice ages, including cooler periods or glacials and warmer periods or interglacials. These glacial and interglacial periods cycle roughly every 100,000 years, caused by changes in Earth's orbit around the Sun. For the past few thousand years, Earth has been in an interglacial period with a constant temperature. However, since the Industrial Revolution in the 18th centuries or 1800s, the global temperature has increased at a much faster rate. By burning fossil fuels and changing how we use the land, human activity has quickly become the leading cause of changes to our climate.
Good day everyone, I'm Maya Macy. So let's move on and talk about the volcanic eruptions. So I know that some of us wonder how volcanic eruptions related to the climate change. So volcanic eruptions are responsible for releasing a molten rock or lava from the deep within the earth. So they are forming a new rock on the earth's surface, but eruptions also impact the atmosphere. Volcanoes can impact the climate change. During major explosive eruptions, huge amount of volcanic gas, aerosol droplets, and ash are injected into the stratosphere. Injected ash falls rapidly from the stratosphere, most of it is removed within several days to weeks and has a little impact on the climate change. But volcanic gases like sulfur dioxide can cause global cooling, while volcanic carbon dioxide, a greenhouse gas, has the potential to promote global warming. The gases and the dust particles thrown into the atmosphere during volcanic eruptions have influences on climate, and most of the particles could from volcanoes cool the planet by shading incoming solar radiation. The cooling effect can be last for months and years depending on the characteristics of the eruption. Volcanoes have also caused by global warming over millions of years during the times of Earth's history, when extreme amounts of volcanism occurred, releasing greenhouse gases into the atmosphere. Even though volcanoes are in specific places on Earth, their effects can be more widely distributed as gases, dust, and ash that get into the atmosphere. And because of the atmospheric circulation patterns, eruptions in the tropics can have an effect on the climate in both hemispheres, while eruptions at mid or high latitudes only have impact in the hemisphere they are within. Volcanoes also release large amount of greenhouse gases such as water vapor and carbon dioxide. the amounts put into the atmosphere from a large eruption doesn't change the global amounts of these gases very much. However, there have been times during Earth history when intense volcanism has significantly increased the amount of carbon dioxide in the atmosphere and caused global warming.
So good day everyone again, my name is Vanessa Roldan. So I'm going to discuss the human activities that contribute to climate change. As humans, some of us is not aware that the activities that we made already affect the environment and activities that we do already contribute to the climate change. Scientists believe that climate change is caused by human activities. We know that climate change refers to the rise and average temperature on Earth. Nowadays, this phenomenon is treated as a major problem of our planet. Why? Because this problem could lead the end of our lives. And regarding this problem, some scientists of NASA had confirmed that the global temperature is being continued to rise for decades to come. And yes, we're the ones who burn fossil fuels, produce livestock and clear trees, and increasing the amount of the heat-trapping gases in the atmosphere. We burn fossil fuel such as oil, coal, gas, which release carbon dioxide gas to the atmosphere. So let me give you all an example of activities that we do that contribute to climate change. First human activity that contribute to climate change is agriculture. Yes, agriculture. And how? In agriculture, by producing food globally, we use fossil fuels in the production. We use fertilizers and pesticides, as well as in the transportation of food. Some types of agriculture also create a lot of greenhouse gases, and keeping animals in large quantities produce a lot of methane. Producing methane, a greenhouse gas, which result a global warming potential 84 times greater than carbon dioxide in a 20-year time frame. The second type of human activity that contribute to climate change is association with industry. Because we use fossil fuels, coal, oil, and gas in the power station across the world to generate energy and electricity. Any one partial BU was burned, they release carbon. They release carbon dioxide or CO2 into the atmosphere. Using fossil fuel to generate energy release pollutants into the atmosphere, such as sulfur dioxide. We can also associate fossil fuels burning with cars like petrol and diesel cars. Because again, carbon dioxide is released from the fumes and even in the exhaust of these vehicles. Also, in releasing a huge amount of carbon pollutants, especially in factories, indeed that humans are the cause of this problem. Because of our unexpected behavior to our planet. We don't know that doing small things like using too much of water and energy can make a big impact to the planet. Because of human activities, climate change tend to affect our planet, considering the Earth, it's full of cities, highways, and machines. Another human activity is deforestation. Forests have a vital role to play in the fight against global warming because forests absorb and store carbon in the trees and soil within them. But forests are cleansed through deforestation. Less carbon dioxide will absorb from the atmosphere, leading to an increase in the carbon dioxide within our atmosphere.
Hi, hello, good day. This is Ria Rubia, and let's talk about carbon dioxide theory. The carbon dioxide theory states that as the amount of the carbon dioxide increases, the atmosphere becomes opaque over a larger frequency interval. The outgoing radiation is trapped more effectively near the Earth's surface, and the temperature rises. Carbon dioxide is a colorless and non-flammable gas at a normal temperature and pressure. So, the carbon dioxide theory was first proposed in 1861 by Tyndall. The first extensive calculations were necessarily done by approximate methods, and there are thousands of spectral lines due to carbon dioxide which are responsible for the absorption, and each of these lines occurs in complicated pattern with variations in intensity and width of the spatial lines. Only recently has a reasonable, accurate solution to the problem of the influence of carbon dioxide on surface temperature been possible. And because of accurate inferred measurements, theoretical developments, and the availability of a high-speed electronic computer, in 1956, physicist Gilbert Plas confirmed adding CO2 or carbon dioxide to the atmosphere would increase inferred radiation absorbed, adding that industrialization would raise the Earth's temperature by just over 1 C per century.
Good day again, I'm Trish May Sanose to continue and add information about Rubia's statement. Carbon dioxide theory also soon spells out to favor, however. Nat Armstrong concluded the carbon dioxide and water vapor absorb infrared radiation in the same spectral regions way back 1990. W.J. Humphreys used this result to argue that a doubling or halving of carbon dioxide, as proposed by Arrhenius, would make no difference in the amount of infrared radiation absorbed by the atmosphere and could not appreciably change the average temperature of the Earth or be at all effective in the production of marked climatic changes.
What are the effects of climate change? Climate change is already having visible effects on the world. The Earth is warming, rainfall patterns are changing, and sea levels are rising. These changes can increase the risk of heat waves, floods, droughts, and fires. A changing climate impacts crops growth and human health. While many people may need to leave their homes, it places certain species at an increased risk of extinction. The effects of climate change are real, and they are already happening. The level of climate change we will see depends on how quickly we cut emission of dangerous greenhouse gases. Even if we were to stop all emission today, we would not prevent some changes. However, the sooner we cut emission, the smaller our change will be.
The effects of climate change span the impacts on physical environment, ecosystems, and human societies due to ongoing human-caused climate change. The future impact of climate change depends on how much nations reduce greenhouse gas emission and adapt to climate change. Effects that scientists predicted in the past: loss of sea ice, accelerated sea level rise, and longer, more intense heat waves are now occurring. The changes in climate are not expected to be uniform across the Earth. In particular, land areas change more quickly than oceans, and northern high latitudes change more quickly than the tropics.
Orbital changes in the Earth's orbit around the Sun, and changes in the tilt and wobble of the Earth's axis can lead to cooling or warming of the Earth's climate, because they change the amount of energy our planet receives from the Sun. Kent and Olson say that every 405,000 years, when orbital eccentricity is at its peak, seasonal differences caused by shorter cycles will become more intense. Summers are hotter, winters are colder, dry times drier, wet times wetter. The opposite will be true to 200 and 500,000 years later, when the orbit is at its most circular. Orbital scale climate changes are caused by subtle shifts in Earth's orbit. There are three features of change over time. The first one is the tilt of Earth's axis. Second one is the shape of its yearly path of revolution around the Sun. And the last is the changing positions of the seasons along the path. Three types of Earth's orbital movements affect how much solar radiation, known as insolation, reaches the top of Earth's atmosphere as well as where the insolation reaches. These cyclical orbital movements, which became known as the Milankovitch cycles, cause variations of up to 25% in the amount of incoming insolation of Earth's mid-latitudes. The Earths of our planet located between about 30 and 60 degrees north and south of the equator.
Scientists drilling deep into ancient rocks in the Arizona desert say they have documented a gradual shift in Earth's orbit that repeats regularly every 405 years, playing a role in natural climate winds. Astrophysicists have long hypothesized that the cycle exists based on calculations of celestial mechanics, but the authors of the new research have found that the first verifiable physical evidence. They showed that the cycle has been stable for hundreds of millions of years, from before the rise of dinosaurs, and it's still active today. The research may have implications not only for climate studies, but our understanding of the evolution of life on Earth and the evolution of the solar system. It appears this week in the proceedings of the National Academy of Science. Scientists have for decades posited that Earth's orbit around the Sun goes from nearly circular to about 5% elliptical and back again every 405 years. The shift is believed to result from the complex interplay with the gravitational influences of Venus and Jupiter, along with other bodies in the solar system as they all whirl around the Sun like a set of gyrating hula hoops, sometimes closer to one another, sometimes further. Astrophysicists believe that mathematical calculation of the cycle is reliable back to around 50 million years. But after that, the problem gets too complex because too many shifting motions are at play. The new evidence lies within 1,500-foot-long cores of rock that Kent and his co-authors built from a butte in Arizona's Petrified Forest National Park in 2013, plus earlier deep cores from suburban New York and New Jersey. The Arizona rocks in the study formed during the late Triassic, between 209 million and 250 million years ago, when the area was covered with winding rivers that laid down sediments. Around this time, early dinosaurs started evolving. The scientists nailed down the Arizona rocks ages by analyzing interspersed volcanic ash layers containing radioisotopes that decay at a predictable rate. Within the sediments, they also detected repeated reversals in the polarity of the planet's magnetic field. The team then compared these findings to the New York and New Jersey cores, which penetrated old lake beds and soils that hold exquisitely preserved signs of alternating wet and dry periods during what was believed to be at the same time.
President Holland said that we have a single mission to protect and hand on the planet to the next generation. In line with this, climate change can cause heavy calamities. And if we don't act now, it's more difficult for us to adapt from this change. The more people, the more we'll continue to do this kind of activities. Doesn't make you feel guilty? Do you now realize that all people in this world is a part of this horrible change?
And as a part of it, we should be the one who help it and make it better.
All of us know that some people trying to figure out a way to prevent this world climate change. We should look at ourselves, think about the small and big things we've done so far, and reflect on it.
You know that every action we make is every word we break. There is always a consequence that could happen to us, and it may lead to.
Climate change is a serious thing, and yes, we people did this to our planet. We had created this problem that has affected many things and people as well.
People should think that climate change is the worst threat to our planet into our life.
But if we try our best, we can save our planet.
We need to be responsible to our doings and we need to take part of trying to stop this problem.
We are the ones who begin this issue. We should also the ones who work to end this and continue happy life.